I'm analyzing a covariance matrix, a tool that shows how different features in a dataset relate to each other. It's like a map of relationships. We have three features, x1, x2, and x3. Think of them as different aspects of something we're studying. For example, if we're studying houses, x1 could be size, x2 could be price, and x3 could be the number of bedrooms. This is the heart of the problem. A matrix showing the relationships between x1, x2, and x3. Each number shows how much the features change together. For example, the 0.8, where x1 and x2 meet, means they tend to change together quite a bit. A larger number indicates a stronger relationship. This is the actual covariance matrix. The numbers along the diagonal, 1.0, 1.0, 1.0, represent the variance of each individual feature. The other numbers represent the covariance between pairs of features. For example, the covariance between x1 and x2 is 0.8. I'm going to test your understanding with a multiple-choice quiz about the relationships I can see in the covariance matrix. I'll give you several statements about how x1, x2, and x3 relate, and you need to pick the ones that are true according to the matrix. Here's the first statement. Is it correct? Next one. Check the matrix and see if this is true. Statement C relates to the variance of x1. See if you can find the answer in the matrix. Last one. This checks if all three features have the same variance. Now let's interpret the matrix's numbers and see what the relationships between x1, x2, and x3 are. Remember that the diagonal shows the variance of each feature while the off-diagonal elements show the covariance between features. Use this information to find out the answers. I interpret covariance matrices to understand how features in a dataset relate to each other. Think of it like this. A positive number means they tend to move together, a negative number means they move oppositely, and a larger number means a stronger relationship. The diagonal shows each feature's variability. This is the covariance matrix. The numbers inside show the relationships between three features, x1, x2, x3. For example, the 0.8 in the top left means x1 and x2 have a strong positive relationship. The 1.0s on the diagonal mean the variance of each feature is 1. Let's check this. Looking at the matrix, the covariance between x1 and x2 is 0.8, while the covariance between x2 and x3 is 0.5. Since 0.8 is larger, x1 and x2 show a stronger relationship, a true statement. The variance of a feature is shown on the main diagonal of the covariance matrix, the diagonal line from top left to bottom right. For x1, I see it's 1.0, meaning it's a true statement. On the diagonal, I see that the variances of x1, x2, and x3 are all 1.0. Hence, this statement is true. The covariance between x1 and x3 is 0.2. This is a small positive number, indicating a weak positive relationship. That makes this statement true. This is the question we are aiming to solve. This is based on the covariance matrix and its properties. This matrix shows the relationships between three features, x1, x2, x3. Each number represents how much the features change together. For example, the 0.8 in the top row, second column shows a strong positive relationship between x1 and x2. The diagonal shows each feature's variance, how spread out its data is. I see the covariance matrix here. The first row, first column shows that x1's variance is 1.0. The first row, second column tells me the covariance of x1 and x2 is 0.8. This continues for all combinations of x1, x2, and x3. I can use this information to answer the questions. This is the core quiz question. We'll evaluate each statement using the covariance matrix above to figure out which is true. Looking at the matrix, I find the covariance between x1 and x2 is 0.8 and between x2 and x3 is 0.5. Since 0.8 is greater than 0.5, the statement is true. The covariance between x1 and x3 is 0.2, which is a small positive number. This indicates a weak positive correlation, so this is also true. The variance of x1 is on the diagonal, in the first row and first column. It is 1.0, confirming the statement. Looking at the diagonal, I see the variance for x1, x2, and x3 are all 1.0. Therefore, all features have the same variance, and this statement is true. I'm analyzing a covariance matrix, a tool that shows how much different features in a dataset change together. Think of it like this: if one feature goes up, how likely is another to go up or down as well? This matrix is key to understanding relationships between your data's characteristics. This is the covariance matrix itself. Each number shows the relationship between a pair of features, x1, x2, x3. For example, the 0.8 in the top row, second column tells us that x1 and x2 are pretty closely related. The numbers along the diagonal, 1.0, 1.0, 1.0, show each feature's variance, how much its values spread out. I'm asking you to interpret this matrix and pick out which statements about the features' relationships are correct. It's a bit like a detective puzzle. This sets the stage. We need to use the matrix to determine which statements about the relationships between x1, x2, and x3 are accurate. This statement is about comparing the strength of the relationships between different feature pairs. Specifically, how does the relationship between x1 and x2 compare to that between x2 and x3? Here, I'm checking if x1 and x3 tend to increase or decrease together, and if the relationship is weak or strong. This asks you to focus on the spread of x1's values. The variance shows how much those values scatter around the average. This statement compares the variance of all the features x1, x2, and x3. Do they all have the same level of spread or variability in their values? I'm analyzing a covariance matrix, which is a tool to understand how different features in a dataset relate to each other. It shows how much they change together. Here's the matrix: 1.0, 0.8, 0.2, 0.8, 1.0, 0.5, 0.2, 0.5, 1.0. Each number represents the covariance between two features. For example, the 0.8 in the top middle and middle top positions means x1 and x2 have a strong positive relationship. This represents the first feature in my dataset. This is the second feature. And this is the third feature in the dataset. This is the variance of feature x1. It indicates how spread out the data for x1 is. A higher value means more spread. This is the covariance between features x1 and x2. The positive value shows a positive relationship. When one goes up, the other tends to go up as well. This is the covariance between features x1 and x3. It's a positive but smaller value, indicating a weaker positive relationship compared to x1 and x2. This is the covariance between features x2 and x1. It's the same as the covariance between x1 and x2 because covariance matrices are symmetric. This is the variance of feature x2. This is the covariance between features x2 and x3. It shows a positive relationship, but weaker than the relationship between x1 and x2. This is the covariance between features x3 and x1. It's the same as the covariance between x1 and x3 because covariance matrices are symmetric. This is the covariance between features x3 and x2. It's the same as the covariance between x2 and x3 because covariance matrices are symmetric. This is the variance of feature x3. I'm now ready to answer some multiple choice questions based on the covariance matrix interpretation. Here are some statements about the relationships I'm going to assess. I need to determine if each statement is true or false based on the covariance matrix I just analyzed. Statement A compares the strength of the relationship between x1 and x2 with the relationship between x2 and x3. I can tell from the matrix. Statement B focuses on the relationship between x1 and x3. Again, I need to check the matrix. Statement C checks the variance of x1 and asks if it's 1.0. I look at the diagonal for this. Statement D checks if the variances of all the three features, x1, x2, and x3, are the same. This is also easily checked with the diagonal. I'm analyzing a covariance matrix. This matrix shows how much different features in a dataset change together. It's a key tool in statistics. We have three features, which I'll call x1, x2, and x3. Think of these as different measurements or characteristics of something we are studying. This is the covariance matrix itself. The numbers inside tell us about the relationships between x1, x2, and x3. For example, the 0.8 in the first row, second column shows the covariance between x1 and x2. The diagonal numbers, 1.0, 1.0, 1.0, show the variance of each feature. This is the main quiz question. I'll need to use the covariance matrix to figure out which statements are true about how the features relate to each other. Statement A compares the correlation between x1 and x2 to the correlation between x2 and x3. I look at the covariance matrix to find those values. Statement B checks for a positive but weak relationship between x1 and x3. Again, I check the covariance matrix. Statement C focuses on the variance of x1, which is found on the diagonal of the matrix. I'll look up this value. Statement D checks if all features have equal variance, again checking the diagonal of the matrix. Simple check. I analyze the relationships between features using a covariance matrix. It's a powerful tool that shows how much features change together. This is the main data I will use. It's a table showing how features x1, x2, and x3 relate to each other. This number is the variance of feature x1. It tells me how spread out the data for x1 is. A higher variance means more spread. This is the covariance between x1 and x2. It's positive and relatively large, indicating a strong positive relationship between them. They tend to increase or decrease together. This shows the covariance between x1 and x3. It's positive, but small, suggesting a weak positive relationship. This is the variance of feature x2. Like x1, it indicates the spread of x2's data. This is the covariance between x2 and x3. It's positive, but less than the covariance between x1 and x2, showing a moderately positive relationship. This is the covariance between x1 and x3 again, same as row 9. I see the symmetry in the covariance matrix. This is because the covariance between features A and B is the same as the covariance between features B and A. That's why we only need the upper or lower triangle. This is the variance of feature x3.